Good afternoon. This is our presentation on Racket, a programming language for programming languages. I am Nathan Red.
And I am Luke Vanderlucht.
Let's get started. So why did we choose Racket for our project? We chose Racket because we thought it'd be a fun experience to be able to learn. Searching for a programming language that was unpopular enough to use, we stumbled across this language called Racket. We dug a little into the surface level of it and quickly found out that one of the main purposes of the language, Racket, is a programming language used to write other programming languages. Right off the bat, we thought that it would be fun to be able to learn and to dive a little bit more into the language. In doing so, we found out that using Racket's IDE, Dr. Racket, it is a user-friendly, beginner-friendly IDE suitable for learning the fundamentals and the basics of programming and languages. So now we're going to get into a brief history of Racket as a programming language. You can see the W.W.W.H of Racket, the who, what, when, and how of Racket. Just give you a little bit of the history of it. PLT, founded by Matthias Fellenson in the 1990s, was originally a research group that soon turned into a project aimed at producing pedagogic materials such as lectures and exercises for new and upcoming programmers. The group later decided that they should create a scheme-based pedagogic programming environment. Many free systems like Mr. Egg, Racket's first virtual machine, and WX widgets were gathered by Matthew Flatt. Flatt, along with Cormac Flanagan, Robbie Findler, and Shareem, whatever his last name is, developed and created Dr. Scheme, a programming environment designed for new programmers supported by PLT Scheme, as well as a research environment aimed at moving towards soft typing. On June 7th of 2010, PLT was renamed as Racket. And then here we have a little history of all of the different versions, and I'll just hit a couple highlights. Version 42 brought a new first-class module system called Units, which allowed the language to be used for large-scale software development. Version 53 resulted in the extensive work on the language and opened many doors for the later version 100, which would also be called 1.0 at launch. Version 300 introduced and support for Unicode and other foreign libraries and enhancements to its class system. Later on, a JIT and an integrated generational garbage collector were added in the 300 series, which led to more improvements in the performance of the language. Racket's DSLs, which are domain-specific languages. This is kind of interesting because, like we said in the title slide, Racket is a programming language meant to program programming languages. And so with this ability for Racket, it can be used for a lot of DSLs. And here's a list of some. We'll just hit a few. Anatomy, the language for generating animal skeletons, especially dinosaurs. Hearsay or Hersey, Lisp with basic inspired syntax. You have a pyramid scheme language for creating Ethereum smart contracts. And we have a slideshow language for generating interactive slide presentations, and a web server language for making web applications.
Next, we're going to talk about the basic features of Racket. Some of this stuff is very similar in other languages, but I'm going to go over how they're a little bit different in Racket. This is kind of a tutorial on how to code in Racket. So for starting, comments. To do just a single line comment, it's just 2 semicolons. If you want block comments, you do the # with a straight line and end it with the inverse. And that's pretty much the simplest thing. Next, we're going to get into some primitive data types. So you can use numbers in a variety of different ways. You have integers, And then you can also specify binary by using £b and then in binary form. Octal, £O in its form, and hexadecimal in £x. To use arithmetic functions, it's a lot different than some other languages. In English, we would say like 1 + 1 is 2. Well, in Racket, the function for the expression is written before the actual elements in the expression. So, an example, 1 + 1 in Racket is written +1 and then space 1. And then 3 times 4 would be written times 3, 4. It's a little bit confusing, but that's just how the way it is. Booleans is just £t for true and £f for false. A little example of using Booleans is not true returns false and true false returns false. Then we have strings like hello world. You can append or combine strings using the string-append command to make hello and world 2 different strings into one string. To print to the console, you're just going to use the printf command. And here's an example of it. And then notice every expression starts with parentheses. Then we get on to variables. To define just a simple variable, you just use the word define, the variable name, and its value. There's no equal sign or anything. It's less typing, very short, sweet, to the point. Then you have for local binding, there's a command called let, that the variable inside only exists inside the let command. So for this, me is the variable name and Bob is the string attached to it. Notice I put me inside the let command and it returns the name Bob. If that me was outside of the let command, it would throw an error because it's only in this local let. And then we can use set with an exclamation point to change a variable's value. So here I have define n to be 5, and then you can set n to add 1 to n, and it becomes 6. Pretty simple stuff. Next, we're going to get into functions. Functions without a return type can actually be created just using divine, kind of like a variable. Otherwise, you use lambda to create a function with a return value. So here's an example of a function called hello, and then it attaches hello to a variable name. So hello Steve just prints out hello Steve. Pretty simple, but just an easy example of a function defining it. And then for equality, we have you can test equality for numbers using an equal sign. So in this expression, we have equals 3, 2. That's false because 3 and 2 are different numbers, whereas equals 2, 2 would return true. EQ with a question mark is returns true if the arguments are equal in memory. So here we have 2 lists, X and Y. They both have the exact same numbers inside the list, but it actually returns false because these are 2 separate lists. They're not equal in memory. It kind of reminds me of in Java how you have equals, equal for equality between numbers, and then for objects you have the dot equals. It's just a different way of showing equality. And then we're going to move on to control flow. So conditionals like if expressions, if true, and then you just list the expressions. You don't have to put if else, if else, if else. You just list all the different expressions. There can be many in this next example. So the cond condition is you can list multiple, as many as you want really, conditions, and then you end it with the else statement. And it's just different options of writing if statements. Then we get on to loops. Loops can be created using recursion, or you can use a built-in for loop and conditionals like when, unless, and break. So here's a simple for loop. It's just for I and 10, print I equals, and then this is just formatting. The a \n is just the formatting of it. and then I. So that would output I equals 0, I equals 1, I equals 2, all the way up to 10. And then you can do the same for loop, but with a conditional of when I is greater than 5. And so it would print I equals 6, I equals 7, all the way up to 10.
All right, now we're going to get into the hello world function or program, as you would call it. Like you saw in some of Luke's examples, there's a lot different than printing out in a different language. You don't have as many of the unique or the common programming features that you would to print out a string or an integer like you would in any other language. So just a glance at the hello world program that we have in Racket, I have two options here. You see the top option is a little bit longer and more complex than the bottom option, and there's going to be more on that to come. So let's break down the top option since it has more stuff. There's more meat to break down here. So you start off in line 1 with the hashtag lang, or the pound lang, as you will. It allows us to be able to specify the language that we want to be able to use. So say, like I said, Racket is useful to program different programming languages. Say you wrote a programming language called yellow. You'd be able to do pound lang yellow and use all the functionality that you built into your programming language called yellow. So lang allows us to be able to specify the language that we want to be able to use for our project. A note here, if you do not specify the language that you want to use for that specific project, Dr. Racket's IDE will automatically assume that you are using the last known language for the last project that you're working in. So it's really important, if you are using multiple languages, to declare them at the start of your project. It will go at the top of your code, most likely like an include statement in C++ and Java, or an import in Python. Then you have in the same line 1, Racket/base. So there's a couple things to unpack here. Racket/base is the most basic language in Racket with only the fundamental features to be able to write code in. If you were to leave the /base out, you'd use the default Racket programming language with much more functionality. You can think of this like Visual Studios and Visual Studios Code. Visual Studios by itself has a lot more functionality than Visual Studios Code, but code is a lot easier to be able to write and execute code in. Moving down to line 2, you see what seems to be familiar to you in different programming languages. You have a parentheses, print, hello world, in parentheses. Looks a lot like a Java or a Python outprint. So the parentheses are optional in our hello world program because our hello world is a string literal, and it's not getting manipulated in any way. All we want to do is define it and print it out. So parentheses are optional when declaring and printing strings like this. In Racket, parentheses are used to define string constants, and you can also use them to use a built-in subclass called a substring. Next thing we have is the print keyword. The keyword print is also an optional feature when implementing the hello world code. For a string constant like this, we want to print. We can do this without the print keyword and still achieve the same result. So now we take a look at our second program that I had on that first slide. With all of that being said, we can reduce all of our program to hello world. Really, it's technically 2 lines of code because you have to have the pound lang for Racket to declare your language, but really our code is 1 line because you'll enter the hello world in a string literal surrounded by the quotes, execute it, and it will print out hello world.
All right, so now I'm going to show you guys a medium program that I created using Dr. Racket. It essentially is just a few sorting algorithms, merge sort, quick sort, and the Dr. Racket's built-in sort feature. And I'm not gonna go into details as to how merge sort works or quick sort or anything like that. You can look that up separate, I guess. But see here at the output, we have a list before sorting. I just created it on the fly, 1, 2, 10, 8, 4, 3, 5, 6. And then it prints the list after it's being sorted by merge sort and the time in milliseconds it took to sort. I'm basically just comparing how fast the different sorting algorithms work in Racket. So a few things that might look a little bit different than maybe this exact same program in Java or Python is to start off, you got this if statement right here. Like we went over in the basic features, it's a little bit backwards. You have the if statement and then, or the less than, and then the A and the B afterwards. That took a lot of getting used to. But other than that, it's not really that many lines of code. That's one of the things that Racket is really great at, is just simplifying and making things less typing, a lot shorter. So yeah, I mean, I can run it a few times up here. You see it gets different results every single time, as it should. But just about, because it's such a small list, just about every time the merge sort takes a little bit longer than the other two. But this is just a nice little example of a full program in Dr. Racket. It has debugging and everything. It's just like any other IDE that you might use, just with a little bit different syntax that we went over in the basic features. And that pretty much sums up this program.
All right, so now we're going to go through a bit of a recap of what we learned about Racket and Dr. Racket today. So first thing we covered was a brief introduction on why and how we chose Racket as our programming language. We thought it'd be cool because it was a programming language designed to program programming languages. Next thing we covered was the who, what, when, and how of Racket. You got a brief history of Racket, how it was developed, and the timeline from when it was developed to where it is now. We also went through the basic features of Racket and programming in Dr. Racket, gave you the fundamentals, how to initialize, declare, and manipulate some integers and strings and the different data types. We also gave you a brief look at some functions and functionalities that you can use in Dr. Racket. Then we moved on to a simple program, our Hello World program, and we broke down some fundamental things that you can pick up from the Hello World program when you first launched Dr. Racket. It gives you, and we ran through a lot of the fundamental things like the #lang, declaring your language, what languages you can use, and also the different pieces and components that go into initializing, declaring, and printing out a string literal like hello world. This is the end of our presentation on the Racket programming language. I hope you learned a lot, and I hope you will consider programming in Racket in the future. This is Nathan Red.
This is Luke Vanderlicht. Thank you for
And
watching.
yeah.